Okay, in this video, I'm going to introduce the concepts of Jupyter Notebooks and Python to get you started, and in the video with some quick tips that will help you with your pre-class assignment. So let's get started. Okay, so in this video, we're going to talk about Jupyter and we're going to talk about Python. Now, you know a little bit about Jupyter already because you've been using the notebooks in class, but we really haven't given a formal description of what they are, where they came from, and the things you can do with them. We haven't been using them to write code in, and today we are going to change that, and from now on, for the rest of the class, we'll be working in these Jupyter notebooks. The other big transition we're going to make is we're going to move to Python. You've been using this very safe block language where you can't really make too many mistakes. And now we're going to transition to Python, which, as you will see, is much more powerful, but also allows you to make a lot of different types of mistakes. And so we want to make sure you don't make too many of those. So let's get started with that. Okay, so Jupyter Notebooks. When we were coding in Scratch, remember we worked in its IDE, that is, its integrated development environment. And what that looked like is it gave us this nice screen. It gave us an area over here to write our code in. All the commands were nicely lined up here. Our output appeared over here. We could change the sprites here. We could change the backgrounds here. It was a nice way to have a workflow of dragging blocks, running things, and seeing them happen. Now, most languages today have a similar type of IDE that they work in. And I'll show you one in a subsequent slide. But what we're going to be using in this class are these Jupyter notebooks. And the way I think about them is they're like an integrated development environment, but they take that concept to very much of a new level. You've already seen so far that in these notebooks you can embed YouTube videos, you can have Google Forms, you can make the fonts different, and so forth. So it's a very, very powerful and general concept, as I'll go into in a little bit more detail. So here's an IDE that you could use for Python. This one happens to be called Spider. There's many of them out there. And you can see over here in this area, there's some code that's being written. There's some output in the form of a graph. So you can kind of do your workflow there. But over here, you have a way to look at your variables. Like, what are your variables? What types of variables? These are called floats, and I'll talk a little bit more about floats later in this video. And you can see at the moment what their values are. Incredibly good for debugging your code if you have a problem, or just seeing what the values of the variables are. Down here on the right, there's some help with the commands. This person was using something called linspace, and they wanted to know how to use it properly, so they got the instructions down here. So you can see that this is a great way to do development. You have your code, you have some details of what's going on, and some help over here. And that's really nice. That's why people like to work in these. Now, Jupyter notebooks are a little bit different in many ways. First of all, as you already know, they run in the browser. And that means you can run it anytime and anywhere from wherever you are. You don't need to download anything onto your computer. What's interesting is that it works with many languages, so it's good to learn. It's transferable to things you might do in the future. But it started in Python as what was called an IPython notebook. And they became so popular, so many people wanted to use them that they generalized them to be used by different people using different languages. So, for example, there's a language, a new language called Julia. And that's what this JU refers to here, because they developed it for Julia. It was originally in Python. That's why this is here, and that's why there's a Y right there. And there's another language very popular in data science called R. And so you can see where the name Jupyter came from. But nowadays, the Jupyter notebooks are used by at least 40 to 50 other languages. Now, where did it come from? What they did is they looked at that workflow that we just discussed in the context of an IDE, but they looked at other types, like from Mathematica, MATLAB, web programming, and so forth, and said, what is a very powerful workflow? And they decided to copy a lot of the good ideas and combine them in a new and unique way that became the Jupyter Notebook. If you just glance at it, it looks most like Mathematica because it uses this concept of a cell, where you can put code in a cell and you can execute that cell. You can execute the cells in different orders and so forth, and even have different types of cells. You can have cells that have comments, cells that have code, and so forth. And a warning, though, with that is sometimes this can cause confusion. Like, so for example, suppose you designate a cell to have a property and you're trying to use it for a different property. So imagine you're trying to put really nice comments, which it allows. I'll talk about markdown soon. And you try to put code in that cell. Well, it's not going to like that. So make sure you know what each code is designated to do and use it properly. The other thing that can mess you up is that the cells can be executed in any order. And the reason that could be important is if you define a variable and then later you start using it in another cell out of order, it might think the variable has an older value than you think it does. So one way to avoid that is whenever you're using your Jupyter notebook, every once in a while you might want to just execute the cells starting from the top and working your way down to make sure that all of the cells are in sync with each other. Okay, so let me give you a little bit of a tour here. Up here at the top is where you'll give your file name, and that's what it's going to save it as on your computer. So make sure that you set that so that you don't have a bunch of files called untitled on your disk. And then right below that, you have an area where there are these menu items, and I recommend going and clicking through each of these just to see what's there and thinking about what all these do. You can save your notebook here. You can move cells up and down with this. This runs a cell. This tells you what's in the cell, and you can change it to code, to markdown, which I'll talk about in a minute, and so forth. So get kind of familiar with all of that just by clicking around. Now, to be honest, I don't use this very much because I use keyboard shortcuts. I use this a little bit, but I recommend walking your way through this just so you know what it can do, but then learn the keyboard shortcuts, and I'll show you a little bit about that in a bit. Okay, and then next, what we have is are in fact the cells themselves. And so here's a cell. You can see it looks like a gray box and it has some code in it. And there's a gap, another gray box with some code in it. Notice that they're numbered. That's the order in which they were executed. And that helps you keep track of what's the most recent information. And then after all this code is put in here, one can then get some sort of output. In this case, we have this nice graph here. Now again, the way you run this is you can use this button up here, or as you've already learned, you can go into a cell, press Shift Enter, which takes you to the next one, Shift Enter, Shift Enter, Shift Enter, Shift Enter, Shift Enter, and you get this nice output. You can do it that way. So there's different ways of doing it. Okay, so that's sort of what a general notebook looks like. There's lots of interesting ways of customizing and so forth, and we'll look at some of those things later in the class. Okay, an important thing in coding is comments, and Jupyter notebooks allow you to make comments that are really high quality and actually end up being kind of fun to do. And they use what's called a markdown language, and markdown language is a way of putting in text using very, very simple commands, almost like its own programming language, that allows you to organize the text in a really nice way. Now you've seen we can add pictures and videos and Google Forms, but let's look at comments. What Markdown does is this. First, you designate a cell as a Markdown cell, and you can go up to that button at the top where it said code and just click on it and change it to Markdown. Or if you're in a cell, you can press Escape and press M, and that will also convert it to a Markdown. Like I said, I like to use the keyboard shortcuts. Then what you do is you go into the cell and you type your comment. It now is not expecting code, it's expecting text. And you put your Markdown in there and you type Shift Enter, and it turns it into very nice looking text. So what do I mean by that? Well, you can do things like this. You can do things like make your words italics. You just put an underscore before and after your word, and it automatically will render it in italics. If you want bold, you put 2 underscores before and 2 underscores after, and your word will be bold. So you might have noticed that we've been using this in this class when we give you your Jupyter notebooks to help you through your assignments. We've been doing these sort of things. The other thing is you can make headers, right, of different sizes. So if you start with a markdown cell with 1, 2, 3, or 4, you get different size headers. And what those are larger, bold words. And I'll show you an example of that in a minute. Now, what if you want to do something else like make a list? Very easy to make a list. You just start a line and you just put asterisks. So you have a line, you put an asterisk, type something, put an asterisk, type something, put an asterisk, type something, and then when you do shift enter on this, it nicely puts bullets there and makes a nice list. You can also do this with numbers. It'll figure out what you're doing. You can do 1 dash something, 2 dot something, 3 something, and then when you do shift enter, it says, oh, this person's trying to do a list, and it makes a nice list for you. You can even add equations. If you've ever used LaTeX before, you can actually put equations in there, and that means that the comments can be very rich and informative. And as you've seen in some of the Jupyter notebooks that we've given you, you can put things like images, you can make tables. You've already seen some of that in what we've given you. Okay, so here's an example. This is a Jupyter notebook, not with the best title, but there it is. This here is a markdown cell, and you can see that there's a large bold. That's one of the headers. It's probably given by this. There's some nice text. It includes an equation that's been LaTeXed, and you can put the equations also in line. So very powerful way to make very informative comments for your code. I've heard that people have actually written books using this. Okay, so like I said, memorize the keyboard shortcuts. So when you're working in a Jupyter notebook, you can use the commands up here at the top, but it starts to be kind of slow. So what I do is I keep track of these keyboard shortcuts. You can always find it on Google. If you ever lose it, you can bookmark it and start to memorize this, and your workflow will become very, very, very fast. And so just again, I just want to give you one little tip here. When you click on a cell, like this one here is clicked, notice it has a green box around it. That means it's in edit mode, which means I can edit the content inside the cell. So if I'm typing, it's thinking I'm trying to edit the cell. That's what this means. Okay. Now, if I go and press escape, it puts me in command mode. Let me clean this up for you. It puts me in command mode, and this box right here will turn blue. And when it's blue, I can give commands to the cell. I can tell the cell to run. I can make the cell move up or whatever. And so there's two modes. So notice what the color is. Blue, I'm giving instructions to the cell, or edit, I'm typing inside the cell. So that can be kind of confusing when you start typing and it's doing completely something you don't want it to do. But it's very useful once you get used to these shortcuts, and you can move back and forth from command mode to edit mode and use all these shortcuts. It becomes a very, very fast and powerful workflow. Okay, now let's move to Python, the language we're going to be programming in. Just a little history. It was created in the late 1980s, December actually of 1989 by Guido van Rossum. This is what it looks like. And it was named after one of his favorite shows, which is Monty Python, which I show here. Not the Python snake, but actually the British comedy routine. So just a quick overview of Python, just a big picture. Python is unlike a lot of other languages you might have heard about, or maybe even some languages you know, like maybe you've heard of C, C++, Fortran, whatever languages that you've heard of in the past or know, in that it is not compiled. It's not a compiled language. What it does is it executes one line at a time as it reaches them. And that's really great for learning to code, because you can type a line, run it, see if it works. Type another line, run it, see if it works. It is extremely easy to debug and prototype in. So in fact, some people will write a code in Python first, prototype it, get it working, test all the algorithms, test everything, and then once the whole thing is working, convert it to one of these other languages to get the speed for running on larger scale computers. Similarly, because Python is so useful, it's often used as a wrapper that the human interfaces with, and the Python then calls the other code, which is also written. So sometimes it's used together with other languages. It's pretty common. Now this makes Python relatively slow. Now in this class we're not trying to do high performance computing, so that's perfectly fine, and a lot of what Python was developed for were things like web applications and so forth, where most of the time was spent in transmitting data back and forth on the internet or waiting for a user, and so it wasn't a big deal. Now in computational modeling and scientific and mathematical applications, that can be a little bit of an issue, but more and more that problem is being solved. Now languages like this are called interpreted languages because each line is interpreted as it's reached. And as I said, that is really nice feature. When you're debugging your code or when you're writing your code, you can debug every line. Type a line in the Jupyter Notebook, run it. Did it do what you wanted? Good. Type the next line. And that way you don't end up with 100 lines of code and you have an error and you have no idea where it came from. Okay, so that's what we're going to be doing. Those are the cons and those are some of the advantages. And so what we're going to do now over the next few weeks is just the same thing we did in Scratch. We're going to look at how in Python do we get inputs, how do we get outputs, how do we define variables, how do we do comments. I already showed a little bit of that with markdown. How do we do functions, if statements, and so forth. So the same ideas that we learned in Scratch, we're just going to repeat it in Python and become really good Python coders. Okay, now one of the first things that we're going to start using is a library called matplotlib. And you might be surprised to know that Python does not have any graphical capabilities at all. In fact, Python has almost no capabilities at all. But what's amazing is that people write libraries for Python that are very powerful, and they make Python one of the most powerful languages if you include all of those libraries. So I like to say that Python is useless for all the things we want to do in this class, except for the fact that the huge ecosystem of people out there are just developing an incredible number of libraries that we can use. And because visualization is so important in this class, we're starting off right away with one of its main libraries, which is called matplotlib. And that, in fact, was designed after MATLAB. So the Jupyter Notebook was kind of designed after Mathematica. Matplotlib was designed a little bit after MATLAB. So you can sometimes see those influences if you happen to know about those other ones. If you don't, that's fine. It is what it is. Okay, so here's an example where I use Matplotlib just to show you how this works, and you'll be doing this pretty soon. So let me just walk you through this so you get comfortable with it. This right here is a markdown cell, and you can see I'm using two different types of font and some spaces and stuff. And then what we're going to do is we're going to import the libraries, and all of your Python codes are going to start with importing some library that you're using for your application. And then what I did, and you'll be doing this in one of your homeworks, so pay attention to this. What I did is I went out to Weather Underground and I grabbed a bunch of data and I put it in Python here, and these are what are called lists, which I'll talk a little bit about later. But you can see I just listed the days, I listed the average temperatures, and I listed the actual temperatures. Okay, and then another markdown cell here to tell me what I'm doing. Notice it's really nice to put these comments as you go, and they're very, very nicely rendered here in Markdown. Okay, then we get here, and this is where we use the libraries. So what we did here is we imported matplotlib, and we told it use PLT as our way of referencing these libraries. So you notice all of these commands start with PLT, and then they have the commands like plot, grid, X label, Y label, and so forth. And this is a pretty customized graph that I end up getting down here, which is the temperature in Fahrenheit versus day for January in East Lansing in 2017. And so you can make these really nice plots very easily. But you notice that making a plot is basically writing a little code and giving it lots of detailed instructions, like blue circles with dashes, and then this one is dash red with triangles. I wanted a legend, I wanted a title, and so forth. And so all of this Python code is doing all of that, bringing in the libraries, storing the data in a list, and then making the plot. And then we can get interesting things out of that plot, like on these days, everybody's saying, oh, there's no such thing as global warming. And then on these days, everybody's saying, wow, global warming is really bad. And so we'll have more fun with this particular example in one of your later assignments. Let's move on. The one thing that's great about Matplotlib and Python is there's so many people that use it. So there's a website called Matplotlib that has in it a gallery, and in the gallery there is an example of everything you could ever possibly want to do. And what's amazing about this is if you click on this or click on this, either one, it will go to a page where it shows you exactly how to do this with all of the code. So you don't need to memorize all of this stuff. So if you go back over here, all these details of how to do this, eventually you might memorize some of it, but you don't need to, because you can go over here and say, I want a plot like that, click on it, and it shows you the code, you copy it. So use Google, use your web browser, bookmark this so that throughout this class, every time you're asked to make a plot of any kind, you have quick access to examples that have already been worked out and look great. Okay, another thing that we're going to be using right away, another library, is called NumPy. Some people say NumPy, so you can decide which one you want to do. And this is a way of doing fast mathematical operations. As I mentioned, Python's a fairly slow language and wasn't originally invented for things like computational modeling. So people made this library to make things a lot faster. Okay, so the first thing we need to address is the concept of variables, and that's one of your first assignments, and I'll get to that in a later slide. And let's think about what we did in Scratch. We used variables in Scratch, but we didn't pay too much attention to them. And what we'll see is that what they were is just what are called real numbers or floats, like 2.13 or something. That's what they were. But in Python, the variables are much more diverse. And for that reason, we have to learn how to not make too many mistakes with confusing the different types of variables in the language. So one really important one is called the list. And we already saw that with that weather data, where you define a variable, you put an equal sign, and then you put a square bracket, you put the numbers separated by commas and another square bracket, and that makes a list. And that, as you saw, was really easy for storing the data and making a plot with it. We didn't have to store x1 equals 4, x2 equals 2, x3 equals 3. That would be very, very cumbersome. So we can put a lot of data in one long list and store it in one little container called a list and use that. Now that is pure Python. That comes with Python. But what people realize is that it doesn't work very well for computational modeling, so they made something very close to it, which is called an array. And that array object comes out of the NumPy library. So you need to import that, just like we imported Matplotlib, to have access to that array. And so we'll be using this array very, very, very soon. So often the top of your code, you will import Matplotlib. That'll be very common. And you will also import NumPy. And you can use these things together very, very commonly. Okay, now the reason for doing this, again, is that NumPy allows us to do manipulations on data at very high speed and do things that are not possible with a Python list. So like, let me give you an example. Even though they look pretty similar, I could not take this and, for example, easily take the sign of each of these numbers and return another list with the sign of those. In NumPy, we can do that. If this were a NumPy array, I would just say y equals sign x, and I would instantly have the sign of all those things, and I can instantly make a plot in 2 lines. And so just keep that in mind. We'll go into a lot more details. I'm just trying to give you here the big picture. Okay, another thing to keep in mind is a lot of people have questions like you have. Anytime you get stuck, there's probably someone else on earth that at some point has gotten stuck for the same exact reason. And there's a lot of sites out there on the internet that can help you. The most common one is called Stack Overflow, or sometimes just called SO. And this is where people can discuss their code, ask questions, people help, people give examples. It is enormously useful when you have a problem. But in general, whether you use Stack Overflow or not, use Google. And get used to coming up with good search terms like loops in Python, matplotlib, histogram, Python print, invalid syntax. If you get an error, just type the error into Google and see what comes up, and probably you will get sent to Stack Overflow most likely. And you'll see people have a discussion because other people probably got exactly the same error. There's no reason to fight with it. Use the internet. All the information is out there. Anything you want to look up is fair game. Okay, so now just to finish this video, I want to give you some Python basics that will help you with your pre-class assignment. Okay, so the first thing I want to cover is how to add a comment. As I showed, if you're in a Jupyter notebook, you can make a cell a markdown cell. Sometimes you might be working in Python and you're not in a Jupyter notebook. That's fine. Python's okay with that. The way you make a comment is you put one of these symbols at the beginning of the line, like this. And it gives you a nice comment. I sometimes use these even in Jupyter notebooks if I want to have comments at this level of resolution and I don't want to have a markdown cell, a code cell, a markdown cell, a code cell. I will actually have a big high-level markdown cell, and then I use these comments inside the actual code cell, and that's very useful. Okay, secondly, how are we going to define a variable? What you do is you pick the variable name, and pick a good one, and you set the variable name equal to the value you want, and so that's how you store things. And so, for example, you might say x equals 3, and now the number 3 is in x, and then if I wanted, in Python there's a command called print. It's actually a function, print x, and I would get 3. And so it's very easy to assign variables. You can see an example right here, which is a little bit more complicated. It takes a bunch of things and creates a variable called temp using the previous value. And so that's something to keep in mind, is that this isn't an equation in the usual sense of math. It's not that x equals 3. It's that what's on the right-hand side is assigned to the left-hand side. So in this example right here, this is the old value, which comes from somewhere up here, and this is the new value, which is then used the next time it sees it, passes it over here. This is the new value, and then that gets passed down. So when you define a variable, it looks like an equal sign, but keep in mind it's not exactly the same as an equal sign in math. It's an assignment statement. Okay, the other thing to keep in mind is that variables have different types in Python. We didn't see this in Scratch because we were just using real numbers or floats, and that's all Scratch needed. But in Python we have variable types that are integers, and that they store things like this. There's no decimal place. So if you asked Python to consider 1 and you asked Python to consider 1.0, suppose I do x equals 1 or I do x equals 1, Python interprets these two things differently, and that can cause some problems sometimes, so keep that in mind. There are other types like strings, like this right here. You can just put quotes and it will store a string of characters, which is very useful. Here's an example over here that's kind of interesting. You can do operations on strings. So here's one where a string foo in tick marks, you can use a single tick or you can use a double quote, that's fine. And you can actually add them together. So you can take one string, add it to another string, and get a single string with them combined, and that's called concatenation. That's called string concatenation. You can do it with 3 and so forth. You can take Monty as a string, put it in this variable called name, Python is the last name, combine them, and you get a full name, Monty Python. So strings are another variable, and they can be combined in the same way. And as we mentioned earlier, there are things called lists, and in NumPy there are things called arrays, and we will be using a lot of these very soon for storing information and being able to use them for plotting. Okay, so let us know if you have any questions, and I'll leave you with this nice Monty Python image.